Hey, good morning. Good morning. Wow, it is so dark. And despite the daylight savings and all, right? So now it's technically supposed to be like 7 o'clock, is it? I keep forgetting. So spring forward, fall back. Um, well, and it was so much darker at 7 o'clock. So I don't know what the hell is going on. So it's the clouds, I think. Um, anyway, so yeah, I'm glad to see you guys back after the midterm. Did you guys all have a good midterm? Was it reasonably okay? Yeah. How many? By the way, how many attempts did you get for them? Hey, switch on your cameras, guys. Everybody, switch on your cameras. How many attempts did you get for the midterm? I Was it one or two?
Just
One attempt.
one.
Okay. All right. Cool. You say, for 2B and 2C, or 2B or 2C, or maybe both of them. I said two attempts for the midterm because for 2B and 2C. I don't know. Maybe it was like this for Walter also when you did 2B. Did you have two attempts for midterms when you did 2B and 2C, Walter?
To be honest, I don't remember.
Yeah, I also forgot. Yeah, but my thinking was that they're more concept heavy, and therefore when students get the question wrong, we give them the explanation also, right? So this is why you got the answer wrong, and then the question disappears. We got to understand it. But then the second time you take the same quiz, next hour or maybe later in the day, you'll remember that. And so you get two chances to get things right because they're more concept heavy in 2B and 2C. But yeah, in 2A, I think it's reasonably easy. I don't think any questions are tricky except for, the edge cases that Aldo. Where's Aldo? You know, um, well, well, we only have like 9 people now in class, and we're asking where's Aldo. Imagine if I had 100 students in class. Where's Aldo? This is like the Where's Waldo game, right? Where's Waldo? This is a little square somewhere in there, and you got to find out. And we can actually play. We can write a little program. We can write a little program in CS2A that takes a screenshot of 500 little stamp-sized images and say, where is Waldo? All right, your program has got to find out which little rectangle is Waldo. All right, so that is kind of cool. It's possible. It is actually possible because just by using, if you know the size of each rectangle approximately, right? And then you have a picture of one of you guys. Well, obviously, there's got to be a picture. It shouldn't be the gray rectangle. It's got to be a picture of you guys. And usually, in standard, you can't be in a different location and all. Home, same place and all. You can actually do a very quick and dirty comparison of individual pixels, right? Individual pixels, and calculate the mean squared error. You guys know about mean squared error? Right? The error is how much something is different from the target. This is the target you're trying to match. This is what you got. So the error is what you got minus the target, the absolute value, absolute, right? So the error is how much you're off from the target. Now, obviously, some errors will be below and some errors will be above. Yeah, because you'll be overshooting or you'll be falling under. So if you just take the sum of all the errors, it's not going to help you much, right? Because some of the good errors will cancel out some of the bad errors. Yes or no? So one way in which you can measure the error of a system that you build later on, okay, later on errors that you build, is to not take the errors and just add them up and say, well, this has got the most error because some of the errors will cancel out, but you got to turn all the errors positive so that you add all the errors up, and the more error there is. So two ways to do it. One is by taking the absolute value. Yes, you take the error is not -5, it's always 5 because it's 5 off from the truth. Yeah. So you just add all the values. So that is taking the absolute value. The other way is much more clever, okay? The cleverer way to do the errors is to not do the addition of the errors, but you take the square of the errors and add them together. So it is a sum of the squares of the errors, okay? Now, why is that better than just taking the absolute values and adding? Right? So suppose I have, do you understand? This is a very important problem statement, okay? Because this will help you like super duper huge amounts, regardless of what you do later on, whether it's just measuring in algorithms or measuring machine learning and data engineering. Machine learning and data engineering, this is absolutely super duper critical, okay? Understanding this, the error and how to, because, when you're training deep nets and so on and so forth, these are kinds of things that you're going to try and minimize because you want to minimize the error, right? Anything that you build, you want to minimize the error of what your system does and what the target requires. Yes or no? So you got to minimize the error. And you can say, well, the total error is a sum of all the absolute values of the errors because some may be right. And I want to minimize that sum. Okay, that technically it is supposed to work, right? Well, yeah, it'll work if you exhaustively search everything. However, that is not such a good approach compared to another approach, which someone else says, well, you know what? Just don't add up all the absolute values. Just screw up, and you have no way of finding out what, how to reduce the error. Rather than adding the absolute values, add all the squares of the errors. So the negative errors will automatically become positive, because -5 will become positive 25 when you square it. Yes? Negative numbers, when you square negative numbers, become positive. So when you add all the squares of the errors, you always get a positive value, so you can reduce that. Yes? Now, so there's two ways in which you can minimize the error. One is you can take the absolute values, sum all the absolute values, and say the sum of the absolute values has got to be the lowest possible. And the other is to say sum of all the squares of the errors, and that's got to be the lowest of all possible, right? Now, when you get to the true target, the true thing, they'll both be the same. Whether it's absolute or mean square, they're both going to be the same. Yes? Because that is the minimum, absolute minimum. The true target value, the actual value is the minimum. However, taking the squares and taking the average of the squares is much better than adding up all the absolute values and taking the average of the absolute values. Can someone tell me why? All right, it's very, very cool. It is really, really cool, and it is important to understand because this basically sets the stage for everything else you're going to do in computer science later on, right? Most computer science courses don't even touch upon these in CS2A. Why? Because these concepts are central to computer science, and they are easily understood by CS2A students, right? In fact, you can go to someone doing high school mathematics, right? You can do high school mathematics, APCS, and you can explain this to them. They'll understand this too. Why is this not being taught? When this is actually a critical part of something you're going to be learning in 2B, 2C, anything else you're going to be doing in life. Or maybe most of you, or some of you are probably doing little startups on the side, right? Because you're learning cool things and you want to try these things out. Like Samir was putting this website together, right? Helping people and all. Where's Samir? Samir, right? I don't know. These guys have, and those of you in the bottom layer of my Zoom screen, you got to switch on your cameras, okay? You got to switch on your cameras because we've got to see your face. Now, why is the averaging much better? Why is the averaging much better? The averaging of the square of the error much better than just averaging the errors themselves, the sum of the errors themselves? Why? Just take a guess, okay? Take a total guess. It doesn't matter. Because I don't expect you to know, but after I explain the reason, I expect you to totally understand it. Okay, you may not know the reason, and so you're going to take a guess, and probably it'll be wrong as expected. So it may be wrong, or you may already know the answer. That's fine too. However, if you don't know the answer, and I say this is why we do it, 100% sure. Okay, I'm 100% sure you'll understand it. And you don't even have to put in a great deal of effort to understand it. It'll just stick in your mind. So next time when someone says this is why we do it, or this is how we minimize the error, you'll know that's why we do it. Okay, and so can someone take a guess why we prefer to minimize the sum of the squares of the errors rather than minimizing just the sum of the errors itself? Yeah, Nemo, go ahead.
Is it because like larger errors are amplified more by the square?
Okay, well, maybe there's a side effect. Okay, maybe there's a side effect, but that is not the main reason. Okay, there is another very, very important reason. Okay, this is another very important reason. But that's a very good guess, by the way. Okay, it's a very good guess because when you square it, the errors, the parabola slope of the parabola is higher after a certain point, so the errors will be much higher. Amplified, yeah. Okay, but that is not the main reason. One more guess, someone else, or maybe even Nemo. Take a guess. Why is it important to sum the squares of the errors, not the sums of the absolute? Right, we're just in casual talking time right now because we won't start our class until about 8:20 or so, which is 5 more minutes. So take a guess. We'll just have this. Every time when class starts, until actually we really get into the lecture material, we'll just have a casual conversation every class, I think. And I think most of these conversations are useful generally. And if not, you can tell me. But so take another guess, okay? Take another guess, and you'll be surprised. Maybe, I don't know. Maybe you'll be surprised, but you'll see why that is. People do that, okay? And I bet that when you actually eventually go to a machine learning class and a professor out there is teaching you this and saying we're going to calculate the mean squared error, okay, and try and minimize this, a lot of your classmates around you may not understand why they're doing that. but you'll understand it. Okay, you'll say that's why we're understanding it. Hey, Mark, go ahead.
I want to ask so we can go over a question on the midterm.
Yeah, totally. You wanna do that now, or shall we just wrap up this thing about the errors that we're talking about really quickly, and then we can talk about that.
Sure, let's do that.
All right. Anybody else want to take a guess, and I can tell you otherwise. Take a guess, because these chances to take a guess, you don't get these chances, right? They're out there when you're talking to people. People who don't say, hey, here's a problem, can you take a guess as to so you only get these chances in class, right? So you should take these opportunities to take a guess. Yeah, everybody should take a guess anytime they get a chance. Okay, so one more, and then I'll tell you the answer. No? Okay, all right. So do you remember the curve? If on a graph paper, what does then the absolute value, when you plot the absolute value on a graph paper, what does it look like? It looks like a V. Does it look like a V? Right? Because it goes like that and goes like that. It never negative. All y is always positive. And so it's like a V. And so at 0, that function, is it differentiable? Can you calculate the derivative of that function at 0? No, right? Because it's a sharp point. It's a vertex. You can differentiate it. So if you cannot differentiate it, that puts a really it puts the optimizer, not the programmer, in a really difficult spot, because they don't have a well known and trusted way to minimize the error. On the other hand, if I took the square of the error, now instead of a V, what do I get? A parabola. Again, it's going to be positive. But since the error is being squared, it's going to be a parabola. Yes? Now, if I can express the error as a parabola, then I can take the derivative of the parabola at any point, and then I can look at the slope of the error, the derivative, and say, well, it's positive, so I got to go this way to reach the minimum error. I got to go this way to reach the minimum error. And so when you have the square of the error, you can actually iteratively, computationally march towards the point of minimum error by just taking the derivative of the curve at any point. Is that cool? Yeah? And so that is called gradient descent, okay? That technique is called gradient descent in machine learning, probably the first technique you'll ever learn, right? When you start learning machine learning, there's so many techniques. And just like here in computer science, in basic computer science, we're learning all these algorithms, right? So we're going to try to learn, binary search, binary trees, shell sort, insertion sort, so many different techniques. All of them, different ways of doing the same thing, maybe. And but we start off with the simple things, right? Start off initially in Tue, we start with recursion, right? And then edge cases, and then binary search in question number 7. We're going to do binary search, more edge cases and things to take care of, right? But it's just a search technique. You can do search in linear search, and so many other ways of doing a search. You learn all the different ways of doing exactly the same thing. And when you learn all the different ways of doing same thing with machine learning, right? So initially they teach you the very easy ways of minimizing error, and gradient descent is the easiest way I think I know, right? So easiest way is take the derivative and keep going, right? And then that'll work regardless of how many dimensions, right? Parabola is just 2-dimensional, right? Even if you have a curve that is like multi-dimensional, it's a multi-dimensional curve, hyperspace. Even there you can calculate the gradient and keep marching towards the error, and it'll take you to the minimum, right? Local minimum anyway. And so that is great. That's what they teach you in because it's very simple. And then you learn many more ways of minimizing the error. That's what it is, right? Most of machine learning, in fact, a lot of it in practice. I'm not talking about theoretical machine learning where you actually get to learn ways of coming up with these techniques. But in practical machine learning, which is what most of these courses teach, is really how to apply these techniques and how to apply gradient descent here, how to apply something else there. And so in the deep nets also, you have data, you have spent a lot of time with the data trying to figure out what this is, and then you find out, this is how you can minimize the error in that case. And the way to do this is to get it into a form that is tractable by computers and mathematics, so you can get the derivative and march towards the right answer. Okay, so that is the brief spiel about something. And yeah, hey, Mark, you have a question about in your midterm. Yeah, so let's take a look at that, and then we can today's class, my plan is, let's take that thing that we did last class, moving star, and we'll try and create a class around that, right? We'll try and create a class around that. And okay, Yeah. So there you go, Mark. We can see your screen. So
Yeah,
which question?
So 16.
Yeah.
So it says assuming the the patron has valid and expired ticket, um it's gonna go into this if, but not into that if, and then it's gonna skip the else and go to the admit patron. So assuming admit patron will print that he should be admitted to the show. So I don't really understand what's the answer for this
What
one.
is the correct answer, by the way? Show me what the correct answer is supposed to be.
I don't know, it's not showing that.
Oh, I see. Okay, all right, cool. We'll maybe try and figure it out. All right, so it looks like when I look at it, it looks like there's a dangling else, and so the
A what?
yeah, else belongs to the first, the outer. Oh, hang on. No. So the else belongs to the innermost if, right? So the nearest. I think I'm, the dangling else is that the else will attach itself to the nearest if statement, not to
Right.
the one that. Yeah. So what happens is that this person has a valid ticket, so it'll enter the first. It'll enter the if statement, and then it'll enter the next if statement, which is false. Therefore, it'll execute the else of that if statement, which is sorry, you don't have a ticket, and then it'll boot him or her from the show. Is that what the right answer is? Is it what you?
I don't know if it's the right answer, but
No, it is the right answer. I tell you that
okay.
is the right answer. Is
So
that
you're
what
saying
you?
you're saying it's the right answer because the else is gonna be
Yes.
to that. Okay.
Yes. And I don't know where, you know what, this question is probably a misleading question, but I left it in there, right? Deliberately left it in there. It's misleading because it is formatted. The formatting of the question is
Yeah, the
misleading.
indentation is wrong.
Indentation is misleading, but the reason I left it there was because it is a very common issue, right? Many programmers will do this, and then they will end up spending hours trying to chase a bug when the bug is right in front of them and they couldn't see it just because of a messy indentation. And so it's better not to get bitten by that, and that's why I left the question in there.
I see. And
does that make sense?
yeah, it does. And for the first one here, it says, so we just have a loop where you sum and you do, you go through the loop one extra time for 0. So it says, how can you improve it while not changing the result?
Yeah.
And I said place the I++ before sum, so you get you do 1, you already add 1, you never add 0, so you never go extra. And
oh, that does an extra 6 though, doesn't it?
yeah, and it's wrong for some reason.
Yeah.
Correct me if I'm wrong, but it's gonna count from 1 and not from 0 because you're gonna increment I
but
before
it's gonna go up to 6 as well though. Because right now it's just gonna go from 0 to 5. If you put the I in before, then it's gonna go from 1 to 6.
Why 6?
No. Well, so what Mark is saying is that the last time it'll enter the loop is when I is 4. Yes, it can't enter the loop when I is 5.
Right, it just let we skip the extra 0, 1 by adding sum only after incrementing the Y. I mean, the I.
So here's the thing, 5, and then it becomes 6, and then it's added to sum. All right, and what was your solution, Mark? You said move the I++ above the sum. But I see. Okay, and then
so you wouldn't add
1.
0, you will just add 1 in the beginning at the first iteration. So you
1, 2,
skip.
3, 4, 5.
Yeah.
Okay. All right. Well, so maybe there's another way in which you can make it better. So the way that I when I made this question, place I++ before. Oh yeah, there is an option, and that didn't work.
No, so this question has a single choice. You see, those are like circles, not squares, which indicates there's only one answer.
But you got this wrong.
Shouldn't
that
it
is
be
wrong.
The last option, if you scroll down, shouldn't it be initialize sum
Wait,
to
you can
1
do
rather
both, I
than-
guess. You can do both.
Yeah, but I'm guessing that's the correct choice.
Yeah, probably.
Hey, go up again. So I is less than 5, which means that. Oh no, yeah. No. Mark, your question, your solution won't work because if we use your solution,
we get
it will
one
add
extra?
5. It'll add 5, wouldn't it? It'll add 5. It'll enter the loop for 4, and then I plus plus will be 5, and then 5 will be added to sum.
Yeah.
Right?
I
But
see.
this loop, so your loop will be different from this loop. In this loop, 5 will never get added to the sum because the last time it'll enter the loop is when I is 4. And so the
Mhm.
last number to get added to sum is 4, not 5. Yes or no?
Yeah, so you're saying I'm gonna add 5 because I'm gonna do I plus plus and it's gonna be 5.
Yes.
Wait.
Let's see.
Professor, shouldn't it actually? I correct my what I said earlier. It should be the I to 1 rather than 0, right? But isn't Mark just saying that you can start at sum equals 1 and then go there? Will it be any different?
Oh, I see. You say sum equals 1 and I equals 1, is it?
I mean,
No,
no,
I
I
equals
think
I
the
equals
answer.
0, but you just keep the sum 1
I mean,
one time.
shouldn't it actually be I to 1 rather, since, well, actually either way I guess works, but it would make more
Well,
sense.
I think if you do sum 1, you're still gonna go 1 extra time. You're still gonna do plus 0.
Yeah,
so-
but if you set I to 1, you see the second option,
Yeah,
initialize the
that's
variable I to 1.
yeah, that
That
will work.
way you skip an extra iteration.
Yeah, honestly, this is like the most easy way to do it. I think all the other ones are like almost working, but not really.
No. This is the only way to do it because
Yeah.
the other way ends up adding an extra number to sum. Yes, the way
Yeah.
you suggested will enter the loop when I is equal to 5. No, when I is equal to 4.
Right, it will do the 4 equals sum plus
4
4.
plus 12, yeah.
And then
it'll
it
do
will
4,
be right, and then
and then it'll add 5 to sum. Because I plus plus is above sum, the addition statement.
right, it's
Yeah.
gonna be 4. It's gonna check if it's smaller than 4. It's like, oh no, it's not. Oh, now I is 5, and now after that they're gonna add 5 basically.
Yes. Right, but this loop will not add 5. It'll stop
Right.
at 4.
Right, if you do 1, it will just stop at 4.
Yeah, so that way you can skip that extra iteration.
Yeah, the problem is that we're incrementing I before we are like we do check before we, you know, the problem is we don't check I before incrementing. We check it, you know, I guess after. Before.
No, we check I and then you increment it before the next iteration. Why? Yeah, when you say before and after, we got to be clear about
Yeah,
iteration.
I lost my train of thought. I meant that because you increment I before you know, before you add it to sum, it's gonna, you know, it's gonna check if it's a 4. When you're gonna go to the 4 iteration, it's gonna add 5 because it's gonna do the
It'll
I
add
plus
5,
plus.
and it should not add 5. Yes, it should
Right.
not add 5. In order to be exactly the same as this loop, it should not add 5.
So basically, what it's gonna do if you have 0, 1, 2, 3, 4, 5, instead of it doing that, and you're trying to what you're trying to do, you're trying to cut it here. But what I'm doing is trying to do this kinda. Does that make sense?
Yes, and you can't add 5. Yes, but you can't add 5. You should
Right.
only add 1, 2, 3, and 4.
Right. Yeah. Okay. I see what you're saying. Thank you.
Yeah. No worries. Yeah, so but these are the kinds of things that we need to spend a lot of time on when we're coding in Tue because these are the corner cases. Because we even see how it's such a simple thing, and Mark and I spent quite a bit of time thinking about it, even though it's all straightforward and it's right in front of us. But it's a corner case, and corner cases always require a little bit more care. And hey, what happens at this end when it's actually 5 or when it's actually 0? those cases. In this case, very benign, but later on you'll be coding some sophisticated stuff, and if you have corner cases off, you'll have really, really weird behavior, and you'll have a hell of a time, a bad time, trying to figure out what's going on there because of some minor corner case early on that you won't even think about looking at. And so that's why it is so damn important in CS2A, I think, to keep hitting the corner cases repeatedly, because when you hit a corner case now, you'll feel the pain, but you won't die. Yeah, it's important to feel the pain and not die, so that later on you will be able to recognize the pain and stay away from it. Because later on, when you're doing some heavy duty stuff, if you feel the pain, you'll also die with the pain. So it's better to face all the really hard stuff right now, and that's why these corner cases are so important, I think. In binary search, in quest number 6, you'll have a whole lot more corner cases to take care of, because binary search is very hard to get right unless you get all the corner cases. This is about 5 or 6 different corner cases. In the same loop, you'll have 5 or 6 different corner cases that you have to take care of to make sure that it works. And each one will be a little bit frustrating because I don't know how many of you are already doing quest number 6, but when you get these things wrong, it's really, really frustrating because it's hard to see where it's going wrong, and you'll be close to throwing in a towel at some point. And it's like super important to feel that, because the amount of frustration you feel when you come across one of these corner case bugs is actually directly related to the amount of exhilaration and joy you'll feel when you crack it. Because if you never felt it's a problem and you fixed it and went forward, it doesn't give you as much of a thrill, right? When you've been struggling with something for a long time, and then you manage to find out why that doesn't work, and this is why you fix it, this is how you fix it, that gives you a great rush. And that night you actually go to bed saying, well, you know what, even if I didn't do anything else worthwhile today, I got that one thing right. Okay, so this day has been worth it. And that feeling you'll get, and that's a very good feeling to have, I think, right? So so that's why corner cases, don't shy away from them. Okay, it's important to get bitten. Try and get bitten by as many of these little bugs as possible right now. Try and get bitten by as many as as when people are out there with antidotes and they can help you, right, before you go into the actual wildies and get bitten by these poisonous insects and animals and people aren't there to help you out. Here is a great way to do it. Okay. All right, so what else do you guys need to talk about? Otherwise, what we can do is today, if someone can take the screen, hopefully not Ashley, because Ashley had a chance last class. Yes. So maybe Philip, Connor, Nathan, I don't know, maybe David also coded, I think. So I think we only have a few people left today who didn't code. No, Robert, you coded too. Or did I ask you this question and you said no last time? No, Robert didn't code. Okay.
I did ask, or is it? But you said that I've already what?
You can save yourself for later or something like that.
Okay.
I think so, but because I said that those who have a little bit of experience already, save yourself for week 7 or 8 or something like that. So when we'll be coding bigger projects. So people who don't have a lot of experience coding, those are the ones who should code now. Okay. So please you don't have any more chances. You only have 2 or 3 more lectures when, if you are not experienced, or you only have 3 or 4 more classes to code, because otherwise later on you'll be coding bigger projects. You won't have a chance to do these little things. Little things are more, instructive, I think, in many ways. So please take the screen, one of you, and then what we'll do is, okay, all right. So this is what we'll do. We will create a class. Yeah. Okay, yeah, that's really cool, because we wanted to play with static variables and all. This time we'll actually get a chance. We'll play with we'll create a class, and a class has got a representation of the string, the screen, one-dimensional screen, right? So we had a one-dimensional screen and we put this char on it repeatedly with the /r. So we'll create a class, an object which has a screen inside of it, so you don't have to pass the screen back and forth. Remember when we did the previous thing, when we had to pass the screen back and forth? Oh, here's a screen and here's how big the screen is and so on. We won't have to do any of that. It'll be so clean. It'll be so clean and neat that you'll actually see the difference. You'll be able to compare this with what you wrote like 3 classes ago. See, wow, you know what? Why didn't I do this, that, and then? Okay, so you'll be able to see that. And so it'll be fun. And I think we'll complete it today, right? We'll complete it today. Thursday, we'll take the same thing and maybe make more embellishments to it and take that to the next level or something like that. Maybe on Thursday, we can actually try and implement a game using what we do today, right? So I think what we'll do today is create a class, and we'll call that class the same as I think I did this many quarters ago, not last quarter or the one before, but I think many quarters ago I did this in class. Not this, right? Something related to this, and I called it special effect display or something like that. Display with effect, display with special effect, right? We'll call this class display with special effect or something like that. Okay, and then we'll do one special effect today, and then for extra credit and fun work after class, you can add any number more of special effects, right? And I'll show you how you can add these special effects. Okay. So who would like to code today? Philip, Connor, Nathan. Philip, thank you. Okay. All right. So put a comment on the top of the page. Yeah. Oh, by the way, before you start, Philip, don't keep the screen and everything. Before you, I forgot to mention. Did everybody get a chance to read Walter's post on Reddit? Where's Walter? Yeah. Okay. Walter, are you here? Maybe you just stepped out. But anyway, I hope you got a chance to read Walter's post on Reddit, because he did some digging into why our code from the other day didn't work. And it's a very interesting point, isn't it? It's a very interesting reason, because the central limit theorem has got to apply. And when you add multiple randoms together, you're supposed to get a bell-shaped curve. And we did this in class, and we didn't get a bell-shaped curve. It was like uniform. Yes. And so it was really puzzling to me. And I talked to Walter. I say, hey, Walter, what the hell is going on? Do you see anything obvious? And then he said, no, I couldn't see anything obvious either, but I'm very curious. I'm going to dig into it more. And then he did some more investigation, and he found out why it didn't work. And he found out how to make it work. And he also posted the fixed version. So I really would highly recommend all of you to take a look at Walter's post and see what the difference is. Because, I don't know if we should even spend time talking about it, but if you have overflow when you're adding bits, binary numbers together, data representation, right? And you have overflow, and the number just rolls around. It rolls around. It's unsigned, okay? It's unsigned and rolls around, keeps rolling around. So it goes from 0 to 32K, and from 32K it doesn't go to 32K plus 1. It goes back to 0 again, which is what happens, right? With unsigned integers, if you keep on incrementing, all of a sudden it'll go back to 0. Yeah, 1 1 1 1 1 1 1 1 1 plus 1 is going to give all zeros with a 1 carry, and so it'll be 0. So it is actually the equivalent of a circular array. I don't know if you know about what is called a circular array. You will actually be implementing a circular array into CS2B. In CS2B, you're going to be implementing a queue based on a circular array. And a circular array is basically you step through all the elements, but after the last element, you go back to the first element again. So it's basically circular. So when you add numbers that have that kind of effect, I think what happens is that any number of numbers that you add just keep moving you around that circular array. And so you're eventually going to still end up at a random number that is, I don't know if it belongs to the same distribution, but it is not normal anymore, right? So it's actually worthy of a really, really interesting mathematical, thinking, right? Meaning that if you have relatives, you have friends and relatives who are mathematicians, it's worth asking them this, right? It is worth asking them, why does, adding multiple randoms, the central limit theorem doesn't work? And it seems to, in fact, preserve the same distribution. It's not even a different distribution. It's the same, uniform, also uniform. But it happens only when you do add up rands that are, not bound. So it occupies the whole range and it's unsigned, right? Meaning it's like I don't know what, because of circular array, but something that is really worthy of thought. And you can ask this question if you have any math relatives, and share the insight in the forums. I'm pretty sure lots of people will appreciate that, right? And in fact, I even encourage Walter to say, well, you know what, this is actually a very good post on Stack Overflow. You should basically take this post and put it on Stack Overflow or Math Exchange and see what the experts can, say about that, because it's actually very useful to know that, hey, you can't keep adding rands to get your, quick and dirty Gaussian anymore. Because that's what I used to do for a long time when I was in research and all. When I wanted a Gaussian distribution to test something out, this is how you can implement the Box-Mueller transform and things like that. But if you want a quick and dirty Gaussian, that's what I used to do. I just used to take a bunch of uniforms and add them together. I get a Gaussian, and that will give me a good, intuition about how my algorithm is going to behave. But that doesn't work anymore. And I didn't know. I wouldn't have known if we hadn't done that experiment. So I would have been doing this. So that was very good. So you should absolutely, refer to the post, and also ping Walter and talk to him and say, hey, thank you for that and all, because I think he did some really cool work there. Okay, all right. So let's put some comments at the top of this program, saying class code for today's date, and then we'll say in the comments, we will create a class called, what did we say? Display with special effects? No, we'll call it display with effect. Display with effect, right? We'll create a class called display with effect. By the way, we're going to use classes from today, right? Classes and objects start today. This is the second half of the course, and generally to make it better learning experience for yourself. Ideally, when you come to class, you should already have read up a little bit about objects, right? So now, could you please raise your hand if you had a chance to read up about objects, right? What in the modules or the textbook, what objects are and what classes are. Just read up. It doesn't matter if you didn't understand it, okay? Because we're going to do something that will make it solid, and you'll understand it after that. But just let me know if you had a chance to read about objects and classes. Yeah, raise your hand. A few people. Okay, all right. So you'll understand it. Okay, those of you, this is what you should do, right? If you don't understand anything that we do today, read up the modules and then go back and look at the code again. Review the lecture, and then you'll be able to see what's going on. Okay, we'll create a class. We'll create a class called display with effect, and say capital D, display with effect, all one, make it capital D for, and then underscore with underscore effect. Or should we just call it special display? No, display with effect is better, right? Display with effect for now. We'll change the name later on. Display with effect. Display with effect.
Professor, did you call my name earlier? I had my headphones on, but I wasn't at the computer.
No. We spent a little bit of time talking about your post and the normal distribution and all. And I, encourage the students to read it and also get in touch with you if they didn't understand what you were trying to say, because I thought it was a really cool post.
Thank you.
Thanks for that, Walter. Okay, so we'll create a class called display with effect. On the next line, you can say this class will maintain an internal representation of a one-dimensional screen and provide methods to modify the screen and to print it. Yeah, I think that's it.
Can you repeat the first part?
Oh, I will. This class will maintain an internal representation of a one-dimensional screen, right? One-dimensional screen. Yeah, next line, I think. Go to the next line after. You see that thin gray line right on the right? That, I think that is 80 columns. That thin gray line that you see in the thing in the middle of the screen, I think that's 80 columns. So you can actually go to the next line when you're close to that. One-dimensional screen and provide methods to modify the screen and display it. Okay, that's all. That's all we're going to do. Very simple. Yes. Okay. Is everybody on board with this? Is this something that you'd like to do today? If you want to do something else, that's fine. Let me know. As long as it has objects and all, we can do it. The only thing is it shouldn't be the pet class that you have to do for your homework and quests. Okay. Anything other than that involves objects, let me know. We can do it. But this is your chance, because once we get deep into this program, this is what we're going to do. Right? If you have another idea, another program, let us know, and then we'll do it. Otherwise, we're going to do this. Yes or no? Everybody happy with what we're going to do? Okay. All right. Good. All right. So, so let's go, and after you're using namespace, hit enter. Yeah. One more enter. And then we will say, we'll basically start our class declaration, right? So you're here, you're going to say class, space. And then what did we call it? Yeah, you can double click on that and copy and paste that here. Display with effect. Yeah. No, double. Yeah. Great. Okay, and then space, and then a curly brace. Space and a curly brace. This is how you declare a class. Okay, space and then a curly brace. Space, a curly brace, enter. Now put a semicolon after the closing curly brace. Okay, now the body of the class, the definition of the class is going to fall inside of that. Okay, this class is going to be defined. Everything is that is part of this class has got to go between the two. That is a block of the class. Okay, so let's go inside the braces. Now the first thing we're going to do is say this class is going to have an internal representation that is not available for other people to go in and meddle with, right? Only this class can change this thing. So we're going to say this is private to this class. So say private and then say colon, private colon, colon, not semicolon. Shift semicolon. Yeah, okay. Now it's funny. GDB, online GDB is not indenting it properly. Well, not properly meaning traditionally, the most common indentation for that is private should be aligned with class. The word private should be under class, right? That is the most common indentation that programmers look for. Okay, there's other ways of doing it too. Can you push private all the way back to the margin? Okay, yeah, and that's good. Right, now go to the next line. Enter there. Now indent it. Now you're going to say a vector angle bracket char. All right, vector angle bracket char, char. No, less than angle bracket char. No, I think it's less than. You got the greater than there. It's a miracle that I can even see it in this tiny increase of size. Yeah, it is less than. Right now, close the angle bracket, and then space, and then we'll call it screen. We'll just call it screen. Right, and then let's say, in fact, you know what? We're going to do it different. Yeah. All right. Put a semicolon right there. In fact, we're going to say this is my screen, and we have not fixed the size of the screen here. Okay. The size of the screen is going to be fixed elsewhere. Okay. All right. So that is our screen, and that's all we have. What else do we need to be private? All right. We'll come to it. Right. If we need other private variables, we'll introduce them later on. Now hit enter. Hit enter one more time. And then say public with a colon, just like you said private. It needs to be aligned with the left margin, right? Colon. Not semicolon, colon, and then align it with the left margin. Yeah, okay. Now hit enter after that. All right, now indent in like you did vector. And by the way, since we're using vector, you need to hash include vector after hash include IOStream. So hash include vector. Okay. Yeah, enter after that too. Put an enter so we can separate. All right, good. Now, and we're not going to put a comment against that vector in screen because it's very self-documenting in terms of the name and all. So here is what we're going to do. So the first thing we want this class to provide is what is called a constructor. Okay, a constructor is a way in which the system can make the object. So the class is just a template. The class says this is how you make the object. It is not the object itself. The class is just a template. It's a blueprint, right? So this is what we're doing. We're creating the blueprint for the class, but we want to be able to make the object from the blueprint. How do you make the object from the blueprint? Then the class also needs to have something called a constructor. A constructor says, I'm going to look at how I'm created, how I'm defined. I'm going to stamp out an object of that class. Okay, so that's called a constructor. So we'll create the constructor there. And the first one is going to be called, so the constructors always have the same name as a class, okay? And no return type for the constructor. So you say display with effect, just like the class name, right? I think you have it in your clipboard. You can just say paste. You can just say paste. It's there in your, you can paste it, right? Display with effect, and then open parentheses, and in here you're going to say size t space size t space size underscore t, which is a data type, yeah, size t space and then width, right? Width, or screen underscore width, width. And then, width, DTH. Now, here's something that we're going to do, which is kind of interesting and cool. You've not done this before, so please pay attention, right? So suppose I say, give me a screen. I'd call the constructor. Constructor, give me a screen, but I don't tell the constructor I want the screen to be this wide or that wide. What width will it choose? It has to choose a default width, right? Because you say you want a screen, tell me how wide it is. So it tells you, you can either tell the constructor, give me a screen that is 80 columns wide, give me a screen that is 100 columns wide, right? Or you can say, just give me a screen. So if you say, just give me a screen, it's got to choose an internal value, some intelligent, reasonable default value, yes or no. So what we're going to do here is provide a default value, right? We'll put a comment on top and all to clear for other students later on. So you say equals after screen space underscore width equals space equals space equals space equals space, and you say default underscore width, right? Default, all uppercase default underscore width. Yeah, and then you got an extra space, I think, in front of the, oh, you got two extra spaces. All right, so default underscore width. Now put a semicolon at the end. And here what we want to do is, can we have static variables? Yeah, I think we can have a static variable inside. Okay, so under private, under your screen, under your on line 13, go to line 13 and hit enter. Yeah, enter. Now you say const size t default width equals space const space const space size t space default underscore width equals. So let's say, shall we say the default width is 80 columns? Yeah, 80 column screen. So 80 columns. Default width equals 80 columns, right? 80. And a default width has to be uppercase, right? Because that's what you're using. You're using that thing uppercase, default width. And then, yeah, semicolon. Okay, now let's put a comment above the constructor. Above the constructor to explain to students. No, not there. Above the constructor, display with effect. No, constructor. The constructor is on line 17. The constructor is what makes the object, right? The constructor makes the object on line 17. So yeah, put a comment above yeah. Go to line 16 and hit enter. Go to line 16 and hit enter. No, at the end of line 16 and hit enter. I'm sorry, Philip. Okay, and confusing the hell out of you. Yeah, right. Enter and tab in and start a comment there. Tab in and then start a comment. Yeah. Right. Say this is the constructor. The constructor. It makes an object. It's a new sentence, right? So you can say this is a constructor, full stop, and then it makes an object of this class. It makes an object of this class. Is it a comma or a full stop? I don't know. Yeah, but you turn that into a full stop and put a space after that. I don't mean to be a stickler, but it'll be easier for a future student, I think. Right? Yeah, turn that into a full stop and put a space after that. Yeah, strangely enough, the reason I said that is because we have a professor in English, in the English department, we have a professor, and his name is Sam White. Okay, and really, really cool guy. And in English, I like talking to English professors because there's really, really, crazy things that irk them. Right? Because I don't know if you've had a chance to talk to English professors, any language professors, right? They are into the language so much that they see something slightly off, and it basically annoys them no end. Okay, and it doesn't annoy me, so I have a great deal of fun watching them get annoyed and say, oh, that really annoys me because and I say, wow, that is so cool. And same kind of annoyance that I feel when someone does programming in a bad way, right? So you write programming in all screwed up indentation. I say, no, that is a wrong program. You should, but the compiler will say it's a perfectly good program, and it's a perfectly good program because you compile it and run it, it produces a desired output. But if you take it to a computer science teacher, they say that's a bad program because now I can't read it and I can't understand it, right? So I think that is the effect. That is the kind of annoyance that Sam feels when he looks at, and he called it, right, several years ago when I was talking to him. And he said, this thing annoys me a great deal. And he actually said it during a meeting. Annoys me because it is called a comma splice. I think, if I remember correctly, he called it a comma splice, okay? And a comma splice is something that annoys him. And he says it annoys a lot of English teachers, not just me, okay? So there you go. I remember Sam White there, okay? It makes an object of this class, which can take the width as a parameter, width, the screen width as a parameter, take the screen width as a parameter, and assumes it to be a default width if it is not given. I think is that reasonably enough documentation for a student later on who's not following, who hasn't attended class but just looking at the code. Yeah. So that's how we need to look at it. Every time you write anything on screen, just put yourself in the shoes of a student who is not in class. Okay. Even though my lectures, I say it's mandatory and all, some students are absent. Right. And we need to cater to them, even though I may reduce points in participation points later on. But we shouldn't make it so that the lectures are hard for them to follow when they come back to it and read. So they should be able to understand the lecture. So look at these things from the perspective of students or from yourself. If you had missed the lecture, think about it. And even if I didn't say this, you should say, well, can we put a comment in there? Because I wouldn't have understood it if I come back later. Okay, so that'll help everybody. Assumes a default width. Assumes a default width if it is not given explicitly. Default width and default value if not explicit, if not given. Okay, good. All right, so that is our constructor. Now what else do we need? Once we have a constructor, we also need to have a method that will set a pixel on that screen. Okay, so on the next line you can say yeah, on the next line, enter. Yeah, enter. Yeah, and you can say bool. This method is going to return a boolean, and you'll find out why it's returning a boolean. I think. Right, bool space set underscore pixel, and then here all you need to give is just the position of the pixel. You don't have to give anything else. You don't have to give, oh, this is a screen width and so on. You don't need any of that. You just say this is the thing. Okay, so you're going to say set pixel set pixel underscore at and then open parentheses, and you say size t column, right? Call size underscore t space call. That's a column number. Call, oh no, col, right? And then put a comment on the line, semicolon, and then put a comment on the same line. Sets a pixel on the screen at the given column, right? Sets a pixel at on screen. Sets on screen at given column. Yeah, I think that's fine. And then put a space before when you start the comment. Yeah, there. And then do we want tell me if you want this, okay? I'm thinking set a pixel here. In my mind, I was thinking set pixel will just go and put a star, okay? Put a star. But later on, you can change this to say set pixel not only takes a column number, but it also takes a character that needs to be put in there. So technically, you can put a star, or you can say don't put a star, put a dash, put a any character. You can pass that character also in, but we're not going to do that, okay? Right. So add a given call, okay? On the next line, you can say bool clear pixel add, bool's clear pixel add. And the same parameters, okay? Same parameters, size t call. Did it autocomplete for you? So did GDB automatically put the closing brace parentheses also? That's why you got pushed onto the other side? I don't know. Sometimes it happens. Yeah, I thought it was really unusual. All right, cool. Now we also, let's say we want to be extra nice to the user of this class and say, well, if you want to clear the whole screen, I don't want to burden you with saying clear pixel at 0, clear pixel at 1, all the way up to width. That's a pain, isn't it? So we can say clear the whole screen. So we'll also create a method called clear screen, and let's make the screen, let's make this void. Okay, so void. Next line. Next line. Void clear screen. All right, clear screen, and it takes no parameters. I think that's all. Oh, we need to have a draw method. Okay, obviously, right? And no parameters. Open, close, semicolon. Yeah. On the next line, one more method to actually draw the screen, and you say void draw screen, right? And again, no parameters. Okay, I believe those are the only things we need in order to go ahead and implement this class. So let's go ahead and implement those 4 methods. And this is how you basically define the methods. Let's go to the line above. Let's go to line 26 and hit enter. Okay, hit one more enter, make some space there. Yeah, okay. Now go to line 27 and let's define the constructor. Okay, so let's say, copy that line, that entire line on 20 and put it there. Put line 20, copy that line 20. Yeah, put it there. Now get rid of that equals default width, right? So when you actually do the definition, you don't supply the definitions are only given in the declaration. So get rid of that, and then get rid of the semicolon, and then instead of the semicolon, say space curly brace, space curly brace. Yeah, enter. Okay, now this is our constructor. We'll put a comment above here saying what it does. But essentially what we're going to do is we're going to say the first thing we're going to do is size the vector, resize the vector to the desired width. So and what we're going to do is if width is greater than 0, no, it's obviously it's greater than 0, right? No, it can be 0 because it's size t can be 0, right? If width is greater than 0, if width is greater than 0, within parentheses, right? If width is greater than 0, greater than 0. Yeah, it puts spaces on both sides of the greater than. Yeah, on the next line, you're just going to say screen indent in. You say screen dot size, screen dot resize. Oh, you didn't get an autocomplete for resize? Can you backspace a few? No, dot R, and then let's look at the autocompletes. No, hit the R again. Delete it and hit R. Yeah, you don't have resize at all. How come you don't have resize for a vector? We're going to do resize, okay? Someone can Google and find out how do you resize a vector. So I say, how is someone Google and find out how you resize a vector in C++? I thought it was resize, okay? Open parentheses and just say screen width. Open parentheses and we say screen width. And then on the next line, you in and back, because this is not part of the, yeah. Now you can do a for loop for size t I equals 0, I less than width. Go ahead. Space I equals 0. No, lowercase I. No, by the way, someone else can also talk Philip through this, right? Because because talking Philip through it is also practice for coding. So if someone else wants to talk Philip through it, you should be my guest. Just go ahead and tell him what to type, right? So can someone complete the for loop for Philip? What we want to do is fill up the vector with all spaces, right? Every vector element should just be the space character. That's all we want to do. So we want a for loop that will basically zip through the vector and put spaces in every cell. That's all. Okay. Can someone complete that for Philip? Why is nobody trying? Why is nobody even attempting to do it? I'm pretty sure that everybody can do it, right? Most of you know how to do it. And even the people who know how to do it are very silent and not doing it. So why? Someone should tell Philip what to do, right? So what we want to do, if you don't know what we want to do, ask, and I'll tell you this is what we plan to do, and go ahead and do it, right? So what we want to do is basically fill up the vector that we have called screen. We need to fill it up with all spaces. So can you do a for loop right there? Imagine this is a midterm question. You're given a vector and you need to write a for loop to fill it up with spaces.
I don't really understand what you're using size t for. Like, I understand that's when you need to stop, but why are you putting that at the very beginning?
Oh, because we don't have a variable called I. We don't have a variable called I, right? So we're creating
Right,
the
but what
variable
does size t has to do with initializing I?
How else would you initialize I? We say int I. Because you need to tell the compiler what type of variable I is.
So you're saying it's a vector?
No, I is just a size t. I is an integer, right? I is an integer.
Right.
Yeah. So you can say, for int I equals 0, or you can say for size t I equals 0, it has to be an integer type.
Oh, so size t is also an integer, basically. So you're saying
Yes.
whatever.
Yes.
So you're
Yes.
basically saying whatever variable is size t, make that I. Right? Is that what happens when you write size t?
No, size t is not a variable. Size t is not a variable. I is the variable.
Right, it's a type.
Yes, it's a type. So you're telling the compiler, inside of this for loop, I'm going to need a counter, and I'm going to call the counter I, and that counter should be of type size t. The data type of the counter is size t. You can ask for, you can say, I don't want a size t, give me an int. You can say an int too, right? But size t is better in this case.
Okay.
Does that make sense, Mark?
Yeah, it does.
Right, so someone please complete the for loop for Philip. That loop basically just needs to zip through the entire vector, right? Screen vector, and set every single element to space. Space is one space within single quotes. That's a space character. That's all it needs to do, right? Someone please do this. It is, consider this your midterm or exam question. And it's very instructive and easy to do. And you should take these opportunities, right? Please do that. Write a for loop there. To complete the for loop, we've already started the for loop. Complete the for loop so that the entire screen is filled with spaces. Not our screen, right? That screen that we have, the screen variable, that vector is full of spaces, only spaces. Can you do that? Come on, someone, please.
Well, don't you need to set up, first of all, like when to stop, and then I++, which is
Yeah, absolutely.
size.
Go ahead, complete it. Call out the code and then Philip will type it in.
So I think for do you want to make it inclusive? I'm not sure. Do we?
No. So here's what we need to do. Here's our vector, and our vector has 80 cells. Yes or no? You got to stay with me every single step, because we have a vector, and a vector is called screen, and it's got 80 cells in it. Yes or no?
Yeah.
Now, all we want to do is go to the first cell, put a space in there. Go to the second cell, put a space in there. And we want to do it for all
Okay.
of the cells.
Okay, so yeah, so that's I smaller than 80 then. So comma for I smaller than
Semicolon,
well,
semicolon.
well either 80 or I think a better thing will be to say size t because size t can vary. Like you
No,
can
not
put
size t. No, not size t. It's you want to start from 0, and how far do you need to go? How big is a vector?
80, but you usually
No, it's not 80. It's not 80. It's not 80. What is the width of the vector? Oh, we didn't store the vector. Yeah, no, it's the vector. The size of the vector is already there, right? The width of the vector is the size of the vector, so it's
Right.
there. Yeah. Okay. So what is the end condition? I'll tell you the end
So the
condition.
end
If you-
condition is should be smaller than that. So for I smaller than size t, right?
No, not size t. I is less than I. So type this in. I'll complete this bit for you guys. So semicolon there, space. Now I space less than space screen dot size. Okay, screen dot size is the number of characters. Is the size of the vector. And I hope someone did a Google and found out. Well, how do you resize a vector? I thought it was resize. I think it is resize. Okay, I've done this many times. Unlikely. And then that is an open close parentheses because screen.size is a function, right? It's a method, right? Semicolon. No, not there. The semicolon after the inside. Yeah, inside. Yeah, and semicolon there, and then space I plus plus. Now, on the next line, in the body of the for loop, all you're going to do is simply say screen square bracket I equals. No, you need to indent in because it's part of the for loop. Yeah. Square bracket I equals. Is there a no? You need to have the closing square bracket after the I. Yeah, and then that is equal to a space within single quotes. Equals space equals space single quotes, right? So it's a single quote space single quote. Single quote. No, quote single quote. No, that's a double quote. That's a double quote. You want a single quote.
Hello?
It's on the same key, I think. You don't press shift.
Yeah. Don't press shift. Don't press shift. Yeah, there you go. And you need a space there. Okay, semicolon. Semicolon at the end of that line, right? And then you can put a comment saying on the for loop, you can put a comment on the for loop, you can put a comment on the line saying this will clear the screen. This will clear the screen. Initialize the screen by clearing it. Or you can put a comment above, put the comment above. Yeah, there you go. Yeah, one more blank line there, and then we start a comment, right? No, you can attach the comment to the method. Attach the comment to the method. Yeah, there you go. And start a comment saying
Hello,
the
can you hear me?
constructor. I can hear you. Yeah. Attach it, and you say this constructor will resize the screen to the requested width.
Hello?
Yes, I can hear you, Mark. Mark, you can hear us? Oh, obviously you can hear us because you're typing. Well, I can hear you. I hope everybody can hear you too. Raise your hand if you can hear Mark.
Can you hear me?
Oh, great. Okay. So this constructor will resize the screen and
Hello?
yes.
We
Yes,
can
who
hear
is
you,
saying
Mark.
hello?
We can hear you.
Maybe you can't hear us. I don't know.
Yeah. Mark, you can. So someone send him a chat message saying we can hear you. Yeah, there you go. Okay. But he can hear me because he's typing what I say. Right. And on the next, and clear it, and also clear it, and also clear it. See, he can hear me. Okay. So and that's enough, right? And I think you can read the comment and you can read the code and you can see immediately what's going on. Yes or no? Yeah. I don't know. You guys are all still in, daylight savings mode or something like that. You're mentally checked out. Nobody's responding. Mark is typing in what I say, but still, it doesn't feel like you are engaged in class.
we're
engaged. Yeah.
we're watching Philip's screen, not Mark's screen, I think, right?
And it says you are viewing Philip Torres screen.
Oh, I'm so sorry. Strangely enough, I thought it was Mark who was typing. I knew it was Philip, and all of a sudden I started thinking it was Mark. Yeah, Philip can hear us, obviously. Philip can hear me. So I don't know if Mark can hear me. Hey, Mark, can you hear us now?
He said in the chat he was having audio troubles, so he's probably trying to fix that.
Okay, all right, cool. Anyway, so Philip's the one who's typing, so and Mark can watch the video, so that's good. Right, so is everybody clear so far what we've done? Right, we know the other methods, 1 or 2 lines each, so we can easily do it. Do you want me to do the other methods, or do you guys want to take like 10 minutes and do the other methods? I can tell you right now, I can tell you that the other methods, how many methods do we have? Well, except draw screen, okay? Even draw screen is just 1 line, because you're going to print the contents of the vector and then put a /r at the end, right? That's all you're going to do. So even draw screen is 1 line. You're welcome to do it, but I can come back and do the draw screen for you. Walter is obviously going to be here too. But do you guys want to take 10 minutes to write out the other 3 functions? What time is it now? Because we have time, right? Before 9, and we'll I can come back at 9 in 10 minutes time, and we'll wrap up the code and actually have it run and see some special effects today. Okay, we should be able to do that. Entirely possible, but with the 10 minutes that you guys are going to take. Okay, use these 10 minutes to wake up first. Okay, I think most of you are still sleeping because of this daylight savings thing or something like that. Got to get more engaged. Talk. Even if you're watching Philip's screen, you should be talking, right? And when I ask questions, just jump in and tell Philip what to do or stuff like that. Okay, so Philip is going to code. Philip, is this okay with you? You're going to code and someone else is going to call out the code. Yes or no?
Yeah, that's fine.
Okay, great. So Philip is going to code. Someone call out the code to flesh out set pixel, clear pixelat, set pixelat, clear pixelat, and clear screen. 3 functions need to be created. Okay, and they're all 3 functions are just 1 or 2 line programs, or 1 or 2 line functions. So can you do this? The format for these functions, just use what I've done, right? So you have to use exactly the same name as a function, but before the function, we forgot one thing. Okay, on line 28, go to the beginning of line 28 and type in the name of the class, the exact name of the class. This class is display with effect. Type in that thing, display with effect. Yeah, that's the name of the class. You can actually double click and can paste again, you'll get it. Yeah, paste 2 times. Yeah, 1 more. Now put 2 colons at 2 colons after that. No, colons. Okay, so any method without that, it is just a free floating method. But when you put that, automatically that method is taken and attached to the class, because inside the class you say, hey, my class has a method called that. Okay, so now this method that's outside is now part of the class. Now you got to do the same thing for those 3 functions, right? 3 other functions need to be written and attached to the class this way. Can you guys do it? Okay, there's a whole bunch of you here, and Philip is going to code, so there's no reason why you cannot code it, right? In my mind, most of you already know how to do it, and if you're not doing it despite knowing how to do it, I can only pin that reason to laziness. Okay, and laziness will cost points. Okay, so if you guys are lazy and not doing it, because I know you can do it. Okay, I know you can do it. It's okay if it's wrong. I don't care if it's wrong. Okay, but if you're not doing it, that's bad. So please go ahead and do it. 10 minutes. Do you want 10 minutes? 3 functions. Got to write 3 functions, 10 minutes. Okay, good. All right, so we have Thomas saying yes, I think. All right, so let's set a timer for 10 minutes. Hey, Google, set a timer for 10 minutes. Hey, Google, set a timer for 10 minutes.
Isn't it Alexa?
Don't you have Alexa?
Well, yeah. Alexa, why didn't I use Alexa? Yeah, I don't know. All right, yeah, I most recently use Google. That's why I use Google, I think. Right, cool. All right. Everybody good? I'm going to turn the laptop around, so I'm not in your face. Complete those functions. I want to see those 3 functions in 10 minutes. By the time the timer goes up, I need to see all those 3 functions. Okay, thanks.
But before we do the next function really quick, I have a question about the display with effect. In the if, why are we using with? Oh, you're back. Oh yeah, why are we using, is that, we haven't declared that, right? Would that not, should we be using screen with?
Yes. Thank you. Thank you,
Okay.
Thomas. It should be screen with.
I was a little
It should be screen
confused.
with. Yeah. It should be screen with.
Okay.
Yeah.
Cool.
You can tell.
Yeah,
from-
that makes a lot more
yeah.
sense.
Yeah. You can fix that too. Thanks.
Yeah. So the next one we're doing is set pixel at, right?
Shall we
Shouldn't
start
the,
with
shouldn't the screen
Should we just go in
size
order?
be screen width? The I less than screen size, shouldn't that be screen width?
No, because I don't think you're using a variable there. Like there you're looking at the size of the vector. So you're not, are you saying like, shouldn't we be using underscore width? This is,
Yeah.
do you remember like string, when you do string, like the name of the string is dot length to get the length of a string? That's, I think, kind of analogous to what's happening here. I still need to read a lot more about this, to be honest.
I see, okay.
I think it's an analogous thing what's happening here. It's not, we're not like using a variable like we've declared up there. You're ascertaining the size of the vector.
So there's a width and there's a height of the screen.
Yeah, so screen width is a variable that we made up. That what you're seeing in line, sorry, it's on another monitor. What you're seeing in line 31 is screen, the vector that we've made up. And then we're saying, okay, let's use the size of that. And C++ already has this, I want to say method, which is dot size. I don't know if that's the right vocabulary term, but and that allows you to get that. But it's not a variable that we made up.
Yeah. Oh, I see. And then you'll just loop through every like thing in the array.
Yeah, so for each like unit, so the size of the, if it's size 10, I don't know, I'm just making up a number, like you'll go through 1, 2, 3, 4, and for each of that you'll put a space in that part of the vector.
But then so is this a vector, so it knows its size? But then doesn't this need nested for loops? Like 4, and then that's like one line, and then don't you need to print the columns too, or there's no column yet?
I don't know.
just look at line 13. That's where our vectors that's where you see the screen initialized, right? Or sorry, no, it's not being initialized. But yes, do you see the vector there, right?
Yeah.
It's only a singular vector. So what you're thinking about is a sort of 2D vector where you would have to go inside the first vector, and then there's vectors inside of those vectors. But
yeah.
Here it's just a single vector, so
okay.
There's no need to deal with that. I think a single for loop should be enough.
Okay, so as long as it's
supposed to be creating functions, guys. We're kind of getting off track here, aren't we?
Not really. It's still talking about the thing. Well, anyway, we can continue. But this is, yeah. Should print it out, right?
I also don't actually get that though. Like, have we said anywhere where the actual size of the vector is?
No. but we have that as a parameter. If you look at line 28, you see the size t screen width.
Yeah.
So this function that we're writing right now, the point of this is to resize the screen and also clear it, right?
Okay.
So the size of it is changing. So like for this function, for example, is able to change the size of it.
Oh. Oh,
So we
you
don't-
got the
yeah, we're-
screen dot resize screen width. Okay. My bad.
Yes, exactly. Line 30. That's basically saying as long as the width of this screen is not, 0, then let's just resize it.
Okay. Gotcha.
Or if the width is greater than 0.
Thank you. I was missing that one.
No problem.
Right. I think for the function set pixel at, all you got to do is say. Actually, what are we setting the pixel to? Is it just going to be a star?
Yeah, well, we can choose something, but we can start out by writing out a function. Philip, if you want to just go on line 33 and start some new lines.
I think all you have to do for it is say for the thing screen square bracket I is equal to the column number. Not inside of display with effect though. You do the outside, make it a new function. Just oh, it is also bool, so we have to return if it successfully does it or not. So I guess if column
Has
is
bool on the left and then screen.
yeah.
Which one are we doing? Set pixel?
I was gonna say not screen. You do
Yeah, so
set pixel
do
at.
set pixel.
There we go. And then give it that brackets
Give it
size t column thing.
not square brackets, parentheses. Yeah, you add it. And what are we using?
Just column, yeah.
Yeah, okay.
And then for the actual thing, if column is less than, because we're doing indexes. Wait, no, it's if column -1 is less than.
Don't forget to close it as well.
Yeah, we say if yes, it's my brain's not working. Is our actual column going to be? Are we going to pass it to it in the index form or like a number form? Let's assume that it is number form and just say if column is less than screen dot size. Then for the inside of that, do screen square bracket column on the inside of this part. Yeah, give it the curly braces after your statement. All right, awesome. And yeah, just a screen square bracket column. Yeah, just call, and then make that equal to like star or something for I don't know whatever character you want. That's good. Put the single quotes around it. Wait a minute. No, character rate. We're good. This is still good. Yeah, put single quotes for the star. Yeah, there we go. And then under that one right there, say return true.
Hey, Google, stop the timer.
Yeah, and then semicolon, and then under that, under the if statement, the exact opposite. Return false. There we go. I think that's it for set pixel at. So it'll say true if it succeeds and false if it doesn't. And then clear pixel at is literally the same thing, but you just set the character at that position to the space. So you can literally just like Control C that whole thing you just wrote.
Don't forget about the trailing bracket that holds the function.
He's just saying on line 41, that's part of that function. So just copy that with it as well.
Yeah. There you go. All right, and set it to change the set to clear. And then change the star to a space. And that's it for that one too. Right, and then clear screen. I forgot how we did that. Is it just setting the character rate of spaces and then printing that? Or is there a different thing we have to go through?
We're doing clear screen, right?
Similar to what we did in display with effect to clear the screen. For loop.
I think he's talking about line 31 and 32, that for loop up there. That's what he's referencing.
I think when you call clear screen, you just create the function clear screen and copy the for loop. I think that's what he's trying to say. So it's a return type void, so you don't return anything, just put void. Clear screen. Clear underscore screen. And just empty parentheses. Now just close it off with brackets. Like the other functions above it, just put brackets. And copy that for loop up there. Or at least. Yeah, just copy it, but maybe with some modifications. I'm just trying to think. Hey, what else do we have? I don't. Anyone have any ideas? Or is that
Don't we also have to do the thing where we set the very last character to \0 so that it can be printed or something like that? And I don't
But-
remember. That was more of a question than
I
anything.
don't think this is printing it, it's just making it empty.
Okay. Then in that case, I think you're good.
Yeah. Because all you're doing is calling the function. You're not actually printing anything out, as far as I can tell. We only do that when we draw the screen.
Are those all the functions we wanted?
We still need the draw screen, I think.
Okay.
Well, I mean, if it's a character array and we're going to draw it eventually, then we do need the \0, right? 'Cause we could in the draw screen thing set the \0 to the character array, but that wouldn't really make sense. It'd make more sense to prep it for being printed again in clear screen.
Actually, I think it's the same kind of for loop, but without like it being equal to empty brackets, you just print out screen I. But it's just called draw screen. So type in void draw screen.
It's a character array. We don't need to though.
We don't need. Yeah, maybe we don't need an array.
No, I'm saying the main thing is we learned a couple classes ago that if you just do cout and then your character array, you can just straight up print the whole thing. It won't do spaces, but I don't think we need spaces between elements for this. But that's also the
Yeah,
reason
we
I'm
just
saying,
cout it.
It's also the reason I'm saying in clear screen we should set the last character to \0 because that lets you actually print out an array without it overflowing and doing the weird characters at the very end. So
Yeah, well, what we can do is we can implement what Robert is saying, and then we can print it, and then we'll see if we have to make those adjustments that Andrew is talking about. Why don't we just try that for now?
fair enough.
So Robert, you were saying that you wanted to do the same for loop as clear screen?
Yeah, except instead of like screen I equals empty brackets, just like cout screen I. Although, yeah. So use the same for loop. But delete the empty like the empty, yeah, quotes. Delete the equals and do cout.
Reverse screen I, right?
Yeah, yeah. Little left. Wow, one's a point right, yeah. I just want to see what it does. So I guess all you need to do now is call the functions in the main and see what it does. So it seems like we've created our functions. I guess we could just, which functions do we start with? The set pixel function? I guess so. Does the does the teacher want us to like show them the functions we made before we do anything in the main?
Well, we also have to think about how are those functions running. For example, set pixel at, that's affecting a screen, right? So you have to think
Yeah.
about how you're going to be testing that out. Because set pixel at has to be acting upon a screen. So you have to figure out, how do I test for that? How do I set it up so that set pixel at can be applied to a screen?
Okay.
Oh, yeah. One other thing too, I just went through and started doing some of these myself, and I realized some of the things I missed. At screen dot size, I'm pretty sure we have to put parentheses behind those because it's calling it a method of screen. And I might be wrong.
Oh,
here.
I think he's talking about 43. On 44, there should be, yeah.
Yeah. Right there. And
Yeah, it's also on line 36.
And 36.
I might be wrong here. I need a little bit of help with this one, but because these are methods of the display with effect class, do we have to specify that in like the top, like bool display with effect : set pixel at, something like that, or is that not necessary? That's a question for someone who's a
So
little bit more
what
skilled.
Andrew's saying, is that you see that display with effect : and then the name of the constructor. He's saying we need that for all of those methods.
Yeah.
Yeah,
I guess
I think you're
should
right.
also put that in, and so the bool and the voids, we just put that there.
Yeah, you need
Just
the return
swap.
types for sure. You need the return types, but
Okay.
you also need to put the copy the name of the class,
Yeah.
Yeah, and then including the double
And put
colons.
in
the
front of
double colons.
names.
Yeah. And put it in front of all of the names.
No.
No.
Don't
No.
replace
No,
the
you need the
bool.
bool. You need the bool. Yeah.
Just put in front of the name of the
Just in front of the
function.
name. Just in front of the name. Okay. Yeah. Command Z, Control
Yeah.
Z, or Command Z. Get rid of that. Yeah.
The left
Right.
of set.
Yeah.
And do it for each one.
Yeah, I like it this way. I'm not the only one talking. Everybody's talking, and then I'm just one of the people who are talking. So that's fantastic. That's the way it should be. Okay, I think I like that. Great. Yeah, I think you need a /R when you draw the screen at the end. After you print out all the characters, you also need to print out cout/R and then
So
a
I
flush,
guess
an
put-
explicit flush.
Yeah.
Yeah, on the next line, you say cout, left shift, a /R character. And that shouldn't be indented because it's not part of the for loop. Left shift, /R within single quotes. /R, yeah. And then on the next line, and then you unindent that line. Yeah, semicolon there, and then the next line. You'd say cout.flush. And everybody knows why we're doing that, I hope. Yeah. We need to do an explicit. No, cout.flush. And then open close.
I guess we're clearing it. That's my guess.
Normally, when you send things out to cout, that stream, it will not appear on screen until it sees an endl character, endl object, because endl says flush. It also flushes when you send a /n, new line.
Don't forget the semicolons.
Yeah, /r may not flush. Yeah. Okay. So that's why we do an explicit
Yeah.
flush. That's great. Now, hang on. Okay, all of that looks good. Now, do you want me to show you really quickly one way of restructuring one of those loops so that it's exactly the same efficiency, nothing changes, it just looks slightly different and fewer lines of code, so that you can keep it in mind. 2 different options to use, and with experience, you'll know which one to use where. Okay, so I'll show you. Go to line 40. Go to the clear method. Clear pixel. Yeah, we'll do that. Okay, you can do this for anyone. Now, what we want to do, you see how you have the if statement and then a braces, because you have multiple statements inside the braces. Yeah, so this is one way. This trick is called it's called an early return. Okay, it's called, you don't have to remember early return and all. This is aesthetics will naturally guide you to it, and people call it, lots of people are doing it. It's called an early return, right? So what we want to do is invert the test so that you don't need curly braces and you only have one in the then statement. Okay, so what we're going to do is say, instead of if column greater than screen size, you're going to say if column is, if instead of less than, you're going to say is greater than or equal to, yeah. And now get rid of the curly brace at the end. Get rid of the curly brace. Enter. And, yeah, and then indent in. Return false. Right? Semicolon. Now on the next line, you don't need you don't need indentation anymore. You can get rid of the indentation in front of screen, column equals and all, right? And then you can get rid of the there you go. You can get rid of the next 2 lines. Now, next 2 lines. Yeah, even the colon closing brace can go, because you don't have multiple. Yeah, that needs to go to the beginning. All right. So now it is exactly the same. No change at all. In fact, efficiency, everything is exactly the same. But the only thing it changes is that you have fewer characters to type now. Yes, because you don't have to indent in that many lines, and you got rid of the closing brace or braces. That's the only thing. So it's just another way. Put a comment there saying this is just another way of structuring the conditional. No, but put a comment above the function, against the if statement. Right? Put a comment there saying just another way of just another way of making the if statement using an early return, right? Early return, put it within quotes, and then people can Google it and find out what that means. I think I'm using the right word for it, but you get the idea, right? Using an early return, early exit, I think, or early return, early exit. Yeah. And then you can say within parentheses, you can say Google it, right? And if you don't find out, you can ask in the forums and I can. Okay, yeah. Does it make sense? It's you've basically done everything, I think, right? The only thing that was missing was a /r character in the draw, and that's been done. All right, what else? What else do we need? So we are able to set individual pixels, and we're able to do okay, well, the main purpose of this method is now we're going to send strings. We need one more method. Okay, so let's go to the top of the class. Right? Yeah, after draw screen, hit enter. After draw screen, line 24. Yeah, enter. Is it void display underscore with marquee effect, right? MARQUEE, right? All underscore. You have to have an underscore in front. This is the name of the function, marquee, right? MARQUEE. Effect, underscore effect, and you're going to pass it a string, right? So and within parentheses, you can say string s. Right? It's a semicolon at the end. Now, Does everybody know what a marquee is? Everybody know what a marquee is? No? Okay, all right. So change the word marquee to ticker tape. All right. So everybody know what a ticker tape is? Hands up if you don't know what a ticker tape is. Okay, all right. So there's a few people who don't know. Right. Marquee and ticker tape, they're exactly the same. So what it means is that letters will start in one corner and they'll basically start drifting like this and move out. So if you've seen planes, airplanes displaying banners, you've seen the banners stuck to the plane, and as the plane is moving and the banner is in the sky. Yeah, that's a marquee because the letters are just moving in space, right? So so if you go to a finance website and you look at the stock prices, right, and they have a ticker tape on top, right? Oh, Dow Jones down 55 points, NASDAQ up, and Google, Microsoft, all these companies, right? So it's always floating from the right to left. That's called a ticker tape effect. So we're going to do that here. How do we do that? It's very easy, isn't it? So, and in fact, I can leave this as an exercise for you, or we can complete it. If we don't complete it today, we'll complete it on Thursday, because that's the only thing we need to do to run it and see the effect. Okay. So, but this will be a very interesting challenge for you to do on your own, and then share it in the forums and say, hey, I completed it, and here's a marquee function. I run it. If you run it in online GDB, see what the effect is, right? You can do all that. And I'll explain what needs to get done. And you can tell me if you want to do it yourself, or you want to, us to code it here. Philip and I can also code it. That's fine. So here's what we're going to do. So here's a screen, and let's assume it's empty, right? And I give them a class, this object, a string saying print hello using marquee effect. Okay, what is it going to do? The first thing it's going to do is go all the way to the right end. This is in a screen.size, okay, and tell print the string starting at the end. Okay, the actual printing will have to be careful, because you have to be careful because there's a corner case there. If the string extends past the right edge of the screen, right, you can't print those characters. So you have to basically just print out all the characters until the end of the screen, and then after that, sleep for a half second. Everybody knows how to sleep for a half second, right? I know you guys are already sleeping because of daylight savings and all, but I mean the program, right? We did this last class or the class before. Sleep for a half second. You print a star, sleep for a half second, right? You did that, yes or no? Remember that? All right. So if you don't remember that, we'll do that in class, obviously, and I'll help you do it. But essentially, what we're going to do is basically go to the end, print the string, okay, and then spaces after that, obviously. Print the string, and then you're going to say, go one more to the left, right? You started at 80, now go to 79 and print the string there again. Go to 78, print the same string again, right? Every time you print the string, print also a space character, because there'll be some, right? So you essentially, that's what you're going to do. You're going to say, print the string, wait half a second, print the same string, one character to the left, print the same string, one character to the left. You keep doing that until you print the string starting at character 0. Then you would have the effect that you have the word which started off at the right margin and slowly marching like a marquee until it scrolls off the left edge of the screen. That's called the ticker tape effect. Everybody, can you visualize this, right? The important step before you program anything is basically trying to visualize what it's going to look like in your mind. So the important thing is, can you visualize what's going to happen when we do that, right? So we're going to say, here's our vector. This is a screen. We're going to print a word there, right? Most of the word is going to be invisible because it's going to be, past the edge of the screen, right? But then we're going to wait a half second and print the same word, one character to the left, right? Wait a half second, one more character to the left, and you can keep doing that. And so that whole word will look like it's marching from the right to the left. That is a marquee effect. Now, that is one effect. Obviously, there's, infinite number of effects you can program, right? There, for example, if you want to take that to the next level, you can basically say, I'm going to take that word that you've given me, I'm going to split it up into two parts, right? Two halves, the string, let's say Robert, okay? So I have Rob here and Ert here, okay? I'm going to split up Robert into two strings of 3 characters each, and I'm going to print the left half here and the right half there, and I'm going to have them both march towards the center, okay? So that's another effect. Yes, you can do that too. Because you know how you can wait for a half second and then print again. and you have a /r character basically going to rewrite so you get the flipbook effect. So you can have so many different effects. Or you can say, I'm going to print the word in the center, and then I'm going to have all the words, letters explode. Okay, explode. So you say, you say Adam right in the middle, and then wait a half second, and then print spaces between the A, D, A, M, right? So A space, D space, A space, M, right? And then wait a half second and insert more spaces. So, Adam appears in the beginning, and then it slowly, with every, second, it appears to explode because the letters are basically starting to, like the expanding
This is some
universe.
kind of
So-
Death Note.
Like Death Note? This is someone
Yeah.
say Death Note?
They're
There's a-
gonna put it on
Wow,
names and
okay.
then we're gonna explode,
There is a
right?
show called Death Note, right? Is there a show called Death Note? Anime show called Death Note?
Yeah.
But there was a show, right? There was a show, and my kids pressured me into watching the first few episodes a long time ago. It was actually fun for a little while. So yeah, but I don't remember. But maybe it's like that, okay? So you can have a letter, and then it basically explodes, a word that explodes into little characters. So many different ways. Or you can have jumbles. You can have jumbled letters, okay? You can have jumbled letters, and then you can keep changing the letters like Matrix. The Matrix movie, where you have, you've been selected, or you are the one, or something like that, but it's all jumbled, and all the letters are changing rapidly, but they all settle, right? The first one will settle into Y, O, U. With time, every half a second, each one will change, but when it reaches a target letter, it stays there. So when you look at the effect, you'll see that the Matrix effect, with all the letters jumbling and slowly settling down until you've been selected, or you're the one, right? So many different effects you can create just using this without using a great deal of code. How many lines is this? 50 lines, 40 lines total, right? So yeah. So including main, we're looking at less than 100 lines of code, right? And you should be able to code all of that. We can code it today if you want. Well, it's time. Unfortunately, we have to go. But you can save this code, and we'll come back and finish it up on Thursday. We'll basically, add more functions, but better than that, ideally, you guys try and write that function to do these special effects, right? And it may not work, doesn't matter, but you had to go. You tried it, and if it didn't work, we'll fix it up on Thursday. How about that? Is that a good idea? Great. So I think this is a nice challenge. Not too big, not too small, and it's guaranteed to keep you excited and interested. So please work on that. I hope to see, right, solutions, not solutions really, this thing finished up with that other method, saying, that method, display with marquee effect, right? Someone implement that also, or you can all get together and implement that. Get together in the STEM Center and implement that, or even virtually over Zoom, implement that and share it. And then if it doesn't work, it's okay, right? You say, well, I did this to the best of our ability, but it's still not working. We'll fix it on Thursday in class, and that'll be a great opportunity. Right now, are constrained because each of you guys, each one of you is in a different place. You're at home, some of you are on a bus, some of you are, out there in the rain and things like that. So it's really hard to get. So here, I actually, I think Foothill is probably considering another way of another new modality of instruction, which is really that, same as face-to-face class, everybody's in class. You will all be on campus in class with your laptops. However, I'll be on Zoom. So, everybody is in one place. The Zoom, but the lectures will be on Zoom, and you'll be in class, and it will be like I'm right there in front of you delivering a class lecture, and you can, just like in class, you can talk to your classmates and everything. And I think that'll be much more fun and engaging, and also draw more people together. Yes, because if each one of you is in your own home, you don't even know if other people are as engaged as you, and chances are. But still, even this is so much better than what I used to do, right? Back in the day, I used to teach in class and had no visibility into what students were doing. Because even the laptop screens are facing you and not me. I don't know if you're watching YouTube. So it was, I go first 3 or 4 people, I can ask questions. The last row, if I ask questions, they're probably just spaced out. And say, oh, what was that, professor? I don't know. I don't understand, right? So typical, most of the standard responses I got to expect were that. But here, no, every time I ask a question, no matter who it is, you're all taking stabs, right? Except today, right? Today you all woke up eventually and started coding. But early in the day today, you guys were all sleepy and not really engaged that much. But hopefully that'll go, right? After after the first couple of weeks of daylight savings, I think you may be okay. But please do that. Please do that. And hopefully, if I'm able to experiment with that other way of teaching before I retire, that'll be really cool for me, I think, because I'm very curious to see how it'll work. If all of you guys are in a class, just like a regular face-to-face class, then basically it'll be a face-to-face class. But I am going to be on everybody's screen, right in front of you, not out there, so you can ignore me, but I'll be right in front of you, and we'll see how that class goes. That'll also be just like this, recorded, and I don't know if it's going to be offered, but I think that Footle is probably thinking about that kind of class, and it'll be nice if we can do that. Well, that is basically all I had to say for today. I would like very much to see this completed, that last function. One or more of you. You may think that I can never do that. That's okay. Maybe you can't do that on your own. Get together with someone else, right? 2 or 3 people, 4 or 5. Just email people on Reddit or Canvas. Email your classmates, get together, get that function going. I'm sure Walter will also be able to help if you can reach out to him. And so I would like to see that, and hopefully we will have another crack at it and run it, and we'll run it and see some effects on Thursday morning. Okay. And if what you write doesn't work, don't worry, we'll fix it up, then run it and see some effects. And maybe hopefully we'll also have time to implement a couple more special effects, right? Not just marquee, we'll have the explosion special effect too, right? On Thursday, we'll do the explosion, unless you guys manage to get to it before I do, right? So if you do the explosion and other special effects also before then, you can all get together and say, well, you do this explosion effect, I'll do the scrolling in from right, and then she can do the scrolling in from left, and all these other things, right? And then maybe someone else can do the matrix effect. All those things we can do on Thursday, right? And we'll have a lot of time on Thursday to do that. And that is basically classes and methods, which we did today. You have to read the modules for some of the concepts, okay? What would So what we've done today is just a class, just the theory of it. Just the practice, but you need to understand the theory behind all of this too, and the concepts, and you have to read the modules in the text to find out what's actually going on. And if you have any questions, you can ask, right? I can talk to you at any length about any level of detail, right? All the way down to the electrons, or to the user. So I can, anywhere you find yourself stuck, just ask, and we'll all have an open discussion in class, and I'll be able to help as much as possible. And I'm very happy with the way this code has turned out. Thanks to Philip mainly for your patience and typing in everything in painstakingly. But thank you, Philip. I think was it a good experience for you?
Yeah, that's pretty good.
Great. Okay. All right. So I hope more people will also volunteer later on. Nathan and Connor, you should absolutely make sure to volunteer. Okay. Not just for points. You will actually know, right? You will know. You talk to Philip. Okay. You'll feel in your bones at the end of class when you've been coding that you're actually an inch or two ahead of where you were before, which you cannot say for sure with a great deal of confidence if you're just sitting through the lecture, right? Maybe if you're sitting through a lecture, maybe you will still be an inch or two ahead. But if you're coding, very high chance, 99.99% chance, you've actually definitely picked up something, okay? So please consider Nathan, David, and all these other people too. All right, anything else? Hey, Ken, you didn't code either, right? Yeah. So consider coding on Thursday. All right, so I have nothing else to say. If you have any questions for me, I'm happy to answer them. I'm happy to stick around, okay? I'm happy to stick around and answer questions if you have them. Otherwise, enjoy the rest of the day, stay dry, and then we'll see each other on Thursday. And before that, hopefully, I should see more of you on Reddit and talking about these problems, right? And Ashley is probably the only one I'm seeing right now who's posting these, little blurbs, interesting things, and you should feel free to just, carry on a conversation, just like, Ashley is taking the pain to do these things, and you can carry on the same conversation or start a new one, and it'll be fun. Okay. All right. Thank you all so much for your patience and sticking around, and Philip also, especially, and Walter for attending class. And I will see you all on Thursday, and feel free to reach out to me or Walter or any of your classmates on the Reddit, especially, right? If you're stuck, if you have any problems, and please do ask. See you later.